Let's see a show of hands. Who's a big fan of the 4.3 liter Chevy V6? You know, the motor that they use in the Cyclone and Typhoon. Those were cool. In my opinion, I like them even more than the Grand National, although the Grand National got all the exposure and got all the press. I mean, guys were running real fast in them, but I really like the Cyclone and the Typhoon because they were trucks and an SUV, and I just thought it was cool. Now, the 4.3 liter has a ton of potential. So what happens when you try to make your own 4.3 liter Cyclone motor? In this video, we're going to take a look at what happened on a 4.3 liter turbo application. We're also going to find out why every turbo test that I run on every motor on the dyno doesn't turn out exactly like you planned it. Now sure, you can build the motor and that works okay, and you can add boost and that always usually works fantastic because anything that's good is even better with boost. But it doesn't always turn out exactly like you planned it, and this is a perfect example. Now I didn't put this motor together, but it just goes to show you that you have to make sure that everything is right before you run it. And in this case we had maybe the wrong turbo. We tried two different ones. It didn't have enough valve spring, and in my opinion, it also didn't have enough camshaft. I mean, there were a few things that I would definitely change to make even more power. But it's important to note, you have to do the combination for the application. Some of us don't want a 7 or 8 or 9,000 RPM motor. Some of us only want a 4 or 5,000 RPM motor, a daily driver that also makes extra power. So a turbo 4.3 with a mild cam, perfect combination. If you're trying to make even more power, the way that I like to do it, add more power NA, then you can make more power at a lower boost number. The problem with making more power NA on a 4.3 liter, there's not a lot of good cylinder heads available. Now we have those aluminum Brodix heads, but that's kind of a specialty thing, and those are left over from when they used to run those in like round racing. But a factory set of heads doesn't flow very well. Even the later Vortec heads don't flow great. Now you can port those heads and make them better, but usually improving the power output on a 4.3 liter involves putting more camshaft in it because there aren't a lot of intake choices for it either. So the problems are kind of compounded. So if you put more camshaft in it, you make more power, but at a higher RPM, you start trading drivability. It's a big deal. So when you're deciding on the power output of your 4.3 liter and where you want your power band, choose wisely. Let's take a look at the results on our turbo test. I have to say I'm really a big fan of these 4.3 liter V6s. I mean, it's just kind of a small version of a small block Chevy, which is exactly why I want it. The 4.3 liter V6 is nice because a lot of things from the small block Chevy just bolt right on. If you take a look at this, we ran a Torque Storm supercharger on it. The water pump bolts on. I mean, I like the fact that that front accessory drive and the head bolts and all that stuff is kind of small block Chevy stuff from the front. So a lot of this stuff works well, which means we have a lot of parts for it. So also, you know, you can take a look at the pistons and those kinds of things. But on the 4.3 liter V6, this one was a non-balance shaft motor. So it was an earlier version, but it was a hydraulic roller cam. The owner of the engine, the guy that put it together, is not sure about the exact year. I guess we could look that up on the block, but it wasn't really important. It was a hydraulic roller motor. It was a non-balance shaft. This one was fitted with the later Vortec style head, so they flowed fairly well. They were not ported at all. It did have a forged piston, and this thing was right at about 9:1, he thought. We put a small comp cam in it. It was a 270 HR hydraulic roller cam. It was 500 lift, 215 duration, and 110 degree lobe separation angle. I don't think the cam is ideal for what was trying to be done here, but as we know, every cam is a turbo cam, and this wouldn't obviously work well with the turbo. We equipped this with an Edelbrock intake manifold. There's just not a lot of options for the V6. Now, he did modify the Edelbrock dual plane intake and cut the divider out of it, making it kind of more like a single plane in hopes that he could get the thing to kind of rev out a little bit more. Ideally, I think a better cam, as we'll see, definitely better valve springs would have been in order for those cylinder heads. To run it up on the dyno, we were going to configure it with this custom turbo exhaust and setup that he made. This was actually going to be going in a sand rail, so they were forward facing, but he made custom headers, which were really cool. The guy, this is Jason over at JFab, and he whipped those things up. They look really nice, and it also allowed us to run this exhaust system NA on the dyno. So all I had to do is, instead of putting the turbo where the turbo mounts, I just used one of my adapters that I'd used from our Big Bang deal, and we ran that adapter to a 3-inch V-band and then a 3-inch V-band section of pipe to complete our exhaust. Now, this thing was run NA also with an MSD billet distributor and a Holley, Ultra XP 650 carburetor, which was more than big enough for this. This thing also had roller rockers on it, and so it was a pretty decent little 4.3 liter V6, equipped with that mild cam and the intake and Edelbrock heads. This 9-to-1 4.3 liter produced 219 horsepower, and we didn't run it any lower than 3,100 RPM, but it made 262 foot-pounds of torque. So you could see it was kind of still a low RPM deal. If you wanted more RPM, it would be better to have a different intake manifold on, but also more camshaft in it. We could run something that was like a 224, 230, and that would work out really good. But here's what happened when we ran our first turbo setup, and we just installed a turbo that I had basically laying around. It was the 76 millimeter from CX Racing, and what we did was we swapped the carburetor over to a blow-through from CSU and ran that on. We actually ran this on a mixture of 100 octane and 91. So we ran the blow-through carburetor, put the bonnet on it. This turbo was the 76 millimeter from CX Racing. And we ran into our first problem. Well, we ran into two problems, actually. The CX Racing turbo was a little bit oversized maybe for this combination. It wasn't terribly responsive. And the other thing that we found that we didn't see NA is when we were running it under boost, we ran into a valve flow problem. This thing made 270 horsepower or so and 300 foot-pounds of torque, but it's nowhere near what the potential of this combination was. So we tried to run the turbo, we ran into a valve flow problem. We didn't really have any other springs to run with this because we weren't prepared to be, changing the combination now. So, but we did have shims, so the next thing we had to do was try to shim this thing. So let's take a look at that, and then we also made a turbo swap. So after our disappointment of running the CX Racing 76 millimeter turbo on this 4.3 liter and running into valve float, so we had kind of two problems. We did what we could. We looked around, we found some shims and stuff, and we were able to shim the thing up by, I think it was 60 or 70 thousandths on the spring. We still had plenty of room for coil bind and stuff, so we just shimmed the spring up to try to get the thing to RPM a little bit more, and we also changed the turbo. Now, this turbo kit was actually configured with a different turbo in this for the sandrail application. He didn't know what the turbo was. There were no markings on it. It was just a turbo. It looked to be about the size of a GT35 kind of. It was a T4 hot side though. But here's what happened when we installed the other turbo. So this was our CX Racing turbo where we ran into valve float. Here's the other much smaller turbo. So as you can see, much more responsive. It kind of wanted to get with the program. It was a much better match for this particular engine at its power output. But then we ran into two more problems. Well, one of them was the same. One of them was still valve float. Even though we had shimmed the springs, we had improved the situation, but only by a few hundred RPM. Even at 52 or 5300, we were starting to lose valve control. The other thing that we ran into is on the CX Racing 76 millimeter turbo, the wastegate that we were using, which was I think a no-name one, would control the boost fairly well, but on this turbo, we did not have very good boost control. We just basically had a rising boost curve, so it was nice that the valve float issue reared its ugly head. Otherwise, this thing would have just continued to climb. I didn't take it apart to find out what spring rate it was or anything. He said it was a 7-pound spring and that it used to run 7 pounds, but again, I didn't check that, and maybe I should have. What we want to do now is obviously there are some issues to be cured here. I'd like to make a more dedicated effort with this combination. I'd like to take the heads apart, put the right springs in them. I'd actually like to also change the cam in this 4.3 liter. I think a different cam is going to help things out. It would be really nice if I could find a single plane intake. He has a single plane intake designed for the Brodix head, so I need to see if that intake manifold will actually work on here. I want to be able to rev this thing out to 6,000 or 6,500 and with enough camshaft We may have to port the head also, so it may be a whole kind of top-end upgrade. I just would like to get the NA power output. I'd like to get the NA power output up to, you know, somewhere in the neighborhood of 275. I mean, even 300 would be a really nice number. That way, when we add boost to it from the turbo, we can, you know, make a fairly serious number at a reasonable amount of boost. The other thing that'll help do is that if we make more power like that, it'll help with our turbo selection. We could get, you know, basically put more turbo on it. And although we were blowing through the carburetor, which obviously does tend to cool the charge air, I would also like to maybe configure this thing with an intercooler. We have an air to water that we use on everything, so I think that that would help the situation also. Even if we were just running dyno water, you know, if we want to get real sporty, we could run ice water through it and, you know, try to make a really big number. But that's what the plan is for the 4.3 liter. We're going to address the camshaft issue, obviously address the valve spring issue, and then make sure that we have, you know, boost control, run an intercooler, and get this thing back up and make more power. I'll tell you what I like about our 4.3 liter turbo test. First of all, I like that it's a V6, super awesome. I like that it's a turbo, again, super awesome. I like that we're doing a blow through with the 85, again, nothing but awesome. Intercooler, very cool. Here's what I didn't like about the test. I didn't like that it didn't turn out the way that I wanted it to, and which is why I want to revisit this test. We need to put this motor back up, or another 4.3 liter, and make a little more concerted effort. I want to make sure that we get this motor to rev out, have the proper valve springs, maybe a better camshaft. We also have a set of the aluminum Brodex heads and a single plane intake. So if we want to improve the power output of the NA motor, we can do that. And we all know if we improve the NA power output and then we add boost, even better things happen. So I want to make sure we revisit this. I really like the idea. I mean, I was a huge fan of the Typhoon and Cyclone motors, and we can make a big version or a more powerful version of that with this 4.3 liter. There's a ton of 4.3 liters out there, so it shows what guys can do. Now maybe they won't go to the trouble of doing all the things that we did, but look, a 4.3 liter with a cam and a turbo on it makes for a good combination. I'm Richard Holder. Make sure to like, share, subscribe, ring the bell, do all that stuff, and I'll keep testing.